Hi everyone, I'm Amit Kumar Das. I'm Senior Software Engineer at Harness, and today I'll be talking about Harness Chaos Engineering and the different type of features it offers. And in particular, I'll talk about Chaos experiments, Chaos infrastructures, and Resilience Probe. So, to induce chaos in your microservices, you need several faults, several hypotheses, and to achieve this, we have Chaos experiments and Resilience Probe. So, without any further ado, we can get started. So, to get started with creation of experiments and creation of infras, you can simply go to the Harness Developer Hub. Here, you'll get a detailed guide on how you can run your first experiment. So, there are different steps given. So, you have to create a project, you have to create an environment, and then you have to install an infra. Post that, if you want to install a demo application, you can do that too. Or if you directly want to jump in to create experiments and target any of the existing microservices in your application, you can do that as well. So if you want to get started with creating your first experiment, there's a great documentation available for that, and we'll be doing every single step which is mentioned here to get started and run our first chaos experiment. So yeah, let's get started. So for this demo, I'm using an online boutique application which is made up of different microservices. So I can show it here. Serial reports. Yeah. So we can see that in my namespace, I have a few different microservices running, which are part of this boutique application, like ad service, card service, checkout service, payment service, etc. So if I go back to my application, I can see all of the services healthy and running here. The card service working fine, the currency service, the catalog service, every services are present here. So what we will do is like we'll induce chaos on one of its service, and we'll check if the application is behaving in a right way. It's not crashing. If one of my card service is down, my catalog service should not be impacted. So we'll be checking if this online boutique application is resilient or not using Harness Chaos Engineering. So let's get started. So to start off with the experiments, we'll first need to create an infra where our target applications are present. So we can just go to environments. We'll create a new environment. I'll give it a name of test demo. I'll be giving this a non-production environment since it's just for the demo. Create, and I'll go in. So here we can see that there are three different type of infrastructures available: Kubernetes, Linux, and Windows. So we widely support a lot of different type of experiments and faults. So in case if your target application is in Linux machine, you can use Linux infra. Or in case if you want to induce chaos on Windows, like increasing the memory or increasing the CPU usage of a Windows application, then you can use the Windows infra. So for the demo, we are using the Kubernetes infra. So I'll click enable chaos. I'm given two options, on existing infra or on a new infrastructure. So on existing infra means that in case if you already have delegates present in your target applications cluster, you can simply use the existing infra. So this is supported by Harness by default. They have connectors which are directly linked to the delegates which are present in the target application cluster, or we can start fresh with a new infra. This is provided by the Harness Chaos Engineering itself. So I'll go with the new infrastructures. I'll click continue. I'll give it a name, Amit boutique demo. I'll click next, and here we have two different options if we want to have a cluster wide access or namespace wide access. So since my application is in a particular namespace, I'll just click the namespace scoped access. I'll give the namespace T, T, and I'll click next. So these are the few CRDs which have to be installed in case of namespace scope. In case of cluster scope, we don't require any of these steps to be done. So I'll just go ahead. So since the namespace is already created, I can skip this step. I have to install the CRDs. I'll go here. So it is applying the CRDs right now. And now I'll install my infra. Let's copy this. I'll download it first. Done. So I can see that the infra is created, but it is still in the pending state because we have not applied the manifest yet. So I'll apply this, and it is installing the execution plane components. I'll just show it what all it is installing right now. Yeah. So if I check the ports in my namespace, I can see that a few execution plane components that are actually required to run our experiments are installed: the chaos exporter, the chaos operator. Similarly, we have a component named as subscriber and the workflow controller. So these are the execution plane components which are required to execute a chaos experiment run. So I think all of my resources are up and running. I should see that my infra getting to the connected state, and it is actually in connected state. So yes, we are ready to go. So moving on to start a chaos experiment, I'll just click chaos experiment. I'll give it a name, delete cart service, and I'll be selecting the Kubernetes infra since I have created my infra in Kubernetes. So I'll just click here. So this is the infra that I created right now. I'll just select this. Next. Here we are given three different options from which we can get started. Either a blank canvas. In blank canvas, we'll get to select the faults from the Chaos Hub. And templates are basically predefined experiments that already have the set of different types of faults. And we can directly go with the upload of the YAML. So for this demo, I'm using the blank canvas. I'll start with a blank canvas, and will be created with this screen in which we can see that a lot of different configuration options are available. This is what we call as a chaos studio, where we can add or delete different faults, we can tune our faults, we can add different resilience probes, etc. So for this demo, I'll be deleting the card service, so I'll use the pod delete experiment. Yeah, and now we'll have to select our application, the target application that we want to, in which we want to induce chaos. So I'll select the namespace. So this, since this is a namespace scope infra, so I'll only list the particular namespace that I have given. In case it is a cluster scoped infra, then you'll get all the namespaces which are available in your cluster. So I've selected my namespace, and I'll have to select the app kind. So the app kind is deployment, and I should see a list of different labels which are pointing to my application. So yeah, I can see that the label card service is available. So this is how we actually target the application on which we want to induce chaos. So we also support the multi-target of application at a single time. We can add multiple labels here. So with this, like, this experiment will target the card service, the ad service, the exporter service as well. So for this demo, we are just targeting the card service. So I'll remove these labels, and then I'll go on to tune my faults. So tuning of fault is basically tuning different properties of that particular fault, like how long I want my chaos experiment to run is 30 seconds, and different other fields are also there, like the RAM time, the period to wait before and after injecting a chaos. Do you want to do it forcefully, or the chaos intervals? I'll give it 10 seconds. Pod affected percentage, how many pods I want to target container, target pod, etc. So these properties differ based on the different faults. So in case of a network experiment, these values will be different. So yeah, I'll now go to the probe section. So probes are basically some pluggable checks that we can add with our faults. So the main concept of chaos engineering is hypothesis. So before running an experiment, we can create a hypothesis that the application should behave in such a way, the application should not go down, or some of our expectations. So with pros, we can add different type of our expectations, that when the application is under chaos, these these things should be happening. So to add a new probe, I can select a new probe, And I'll go to a new tab to show the addition of probes. Yeah. So, as I told, resilience probes are basically some pluggable checks which are required to validate our hypothesis. So, with harness chaos engineering, it offers a vast variety of probes. So, depending on the infra type, we have different type of probes. So, in Kubernetes, we have HTTP probe, command probe, Prometheus probe, Kubernetes probe, SLO probe, Datadog probe, and Dynatrace probe. So with HTTP probe, it basically checks if an endpoint or a URL is accessible when your application is under chaos. So it checks for the status code and the response body. So command probe is one of the most important probe that we use in most of our chaos faults. So basically, with command probes, you can provide different shell scripts and execute it once the chaos is happening in your cluster. Prometheus probe is used to fetch the Prometheus details, and once the application is under chaos, we can check if the values are meeting our expectations or not. And similarly, we have a Kubernetes probe. So with this probe, we can do some CRUD operation of different Kubernetes resources. We can create different services once the application is down, just to check if the application is going down, and if we enable one of the service, is it uh, behaving in a resilient way or not. Similarly, some integrations we have with the existing harness platform, which is the SRM platform, and we have an SLO probe, which basically shows the service level objectives are met once the chaos experiment is executed. And other than that, we have some APM probes, which are Datadog probes and Dynatrace probes, just like the Prometheus probe. Uh, these use Datadog metrics and Dynatrace metrics to uh, validate our hypothesis. So for the existing demo, I'll be using the HTTP probe. So I'll give it a name, access front end. I'll click next. I'll give it a timeout of 10 seconds, interval of 2 seconds, 2 attempts, polling interval of 2 seconds, and I'll click next. So the URL that I'll be providing is the front end URL of my application, which is this. And I can skip these. I'll select the get method. I will so I want my application to be my front end to be running even in case one of my services is down. So I'll be giving this criteria. The When I'll try to access this URL, I should be getting a 200 response. So this is how I can set up my probe. So I can see that my probe is currently enabled. There are no runs right now. So once I add this probe in the existing experiment, we should see an existing run coming up here. So moving back to our experiment, so since we were already tuning our fault, so the next step is addition of probes. We have done the target application tuning of the fault, and now it's time to add the probe. So I'll add a new probe here. So this is the probe that we just created, access front end. I'll add this probe, and there are different type of modes on which we can run these probes, either on the start of test, either on the end of test, either before and after the test, continuously throughout the execution of experiment, or only that period when the chaos execution is happening. For the demo, I'm using the continuous mode. I'll apply the changes, and uh, the other tabs are basically some advanced features that we offer, and one of them is coupled with the SRM module. So in this SRM events, we basically send events once the chaos injection is happening, and the advance is just to enable or disable the advanced properties like run as user or run as group. So I'll just apply these changes, and to validate if my changes are successfully applied, I can go to the YAML section, and I can see that all of my target application details are here. I've applied a probe in my fault, which is the access front end probe, and I've also updated the uh, tunables of my fault. So everything is fine. Now we'll just save this experiment. So the experiment is saved. I can go back to my experiment page and I can simply run this experiment now. So we can see that the experiment has started, and if I come back to my cluster, I can see that the experiment pod is being created. So it will take some time, and meanwhile we can wait for a few minutes to see how it is going to affect our boutique application once the kiosk execution is happening on the targeted service. So the experiment creation step is completed. Now we'll be inducing chaos. The fault is now executing. So we can see that a pod delete experiment pod has been created, and this will actually restart the card service. So it is in currently running state. Once the experiment pod starts running, we should see that all the tunables that we have set, all the probes that we have set will be executed, and we'll see the effect of this on the boutique cart application. So yeah, this is in running state, and in a few seconds we can see that the card service getting restarted. Yeah, we can see that the card service is down. If I go here, if I refresh the page, I can see that the whole application is not responding at all. Is still under not ready state, and we are not able to access this page, and we can see that could not retrieve the card information. So with this we can conclude that this application is not resilient. We are not able to access the front end, we are not able to access any of the services because they are tightly coupled with each other. So we'll just wait for the application to come back online. So meanwhile we can also check what are the logs that we are getting. So yes, the probe that we have added was to check if the front end is accessible or not, and we can see that the access front end probe has failed because the value is 500. What we have added in our hypothesis is even if the card service is down, we will be able to access this front end endpoint. It should be equal to 200, but the actual value we are getting is 500, which is the service being not available right now. So the experiment is behaving as we have expected, but the probe is actually failing, and we'll wait for a few moments for the experiment to complete. And meanwhile we can see that the cart service is back online, and if I go back to the boutique shop, I refresh this page, yes, we are back to a steady state where everything is working fine. So let's wait for a few moments for the experiment to complete, and then we'll go through the logs as well. So with harness chaos engineering, you get real-time logs which are streamed directly from your cluster, so that the debugging or insights of the experiments are clearly available during the execution itself. You don't have to wait for the completion of experiment. You can see it in real time. So just waiting for the cleanup action to complete. So it's deleting all the uh, redundant pods which were created during the execution of the experiment. So yes, the second step is also completed. We should see this state getting completed in a few seconds. It's already done. And it's the last step of cleaning up all the resources that we have created during the execution of the experiment. So this is the last step which will be happening, and it is also done. So we can now check that the overall resiliency of that application of this particular experiment is 50%, because the health check has passed. This is a default check which looks for the service availability, and this is the probe that we have added to check if the front end URL is accessible or not when the chaos is ongoing. But instead of getting 200, we got 500. Hence, the probe has failed. Since two of the probes were there, one of them has failed and one of them has passed. The overall resiliency of your application for that particular service is 50%. And we can check the fault configuration here. It was the namespace, the kind was this, the label was card service since we're targeting the card service. The all the tunables are listed here. Logs are there. We can actually go through the logs as well. We can download the logs as well. This is one of a good feature we are providing. So we can see that the in the logs that it has shown why the probes have failed. And going back, this is the overall summary of our experiment run. We can edit this experiment, we can clone this experiment. By editing, I mean we can go and add more probes, we can update the tunables. Cloning will create a completely new set of experiment with the same properties. And we can view the report as well. If I click on view report, I can see that the experiment resilience score is 50%. The name of the experiment, the probes that were present here, the overall status, the probe statuses. So everything is there, and we can download this report as well. So going back, we have some few more functionalities that we offer with the experiment. So this is when we run an experiment, and what if I want to stop an execution in between? I don't want to run the experiment because I see that my application is not behaving as intended. So this a stop button as well, which will actually stop the chaos execution. So once my experiment starts, I can click on this button to show that how the execution is stopped gracefully. So we'll just wait for my experiment to come to the fault injection state. Yep. So the first step is completed. We'll go to the second step. The second step has also started. We should see the events flowing here. Yeah. So the fault injection step has started. Now I want to stop this fault execution. So I can just simply click stop. And but we should see that the experiment being marked as stop, and all the required ports, all the execution plane components to be removed from our cluster, so the experiment won't start at all. So yes, we can see that it is the fault and the experiment has been marked as stop. Overall resiliency is 0%, and with this this completes our stop flow as well. Yeah. So apart from this, we have some more functionalities, like adding a cron job for our experiments. So with the in Kiosk Studio, you can go to the schedule tab. Here we have two different fields, two different radio buttons. First one is for the single run that we run manually. The second one is for a cron if you want an experiment to recur. So we can provide a specific time, like run every 5 minutes, run every 10 minutes, and it depends on the configuration that you want to provide. And we can simply set a schedule, and we can enable the cron. So I can just show and do it right now. I've set it for 5 minutes, every 5 minutes. So this experiment will run every 5 minutes. I'll set the schedule. This is done. I'll save this experiment, and I can see there's an option to enable the cron. So this experiment won't start until unless I enable this cron. So I can simply click on this button, and the experiment, the cron experiment has been enabled. So I guess from 5 minutes from now, this experiment will be triggered, and it will continue to go on until and unless we disable this cron. So I'll just click on disable. So this is how we can like enable and halt the cron schedules, and this has been converted to a cron experiment. To run this experiment in a single run, we can also click run now. So it will run irrespective of being a cron. It will run it in a single run as well. So yeah, these were some of the features that are there present in the Kiosk experiment side. I can also show the run history that we have. So I have 3 executions here. We can see a report of the same. We can see a graph of the overall resiliency score based on individual runs, and we can also see the run report as well. So yeah, this is pretty much it, and in the overview page you can see the experiment runs. And yeah, so this was more of the execution of experiments, different type of faults, and how you can install Kiosk infrastructure in your clusters and and create experiments and run experiments. So in the upcoming videos, we'll be talking in depth about chaos infras, chaos hubs, and other features that harness chaos engineering offers. So thank you. That's pretty much in this demo. Thank you.